My name is Travis Hosting. I'm with the Wood Center at Iowa State University. I'm here to do a demonstration, I guess, of the IML Resistograph PD400. This is the model we have, and I believe it's the same model that LTAP has purchased and will be sending out for loan. All the 400 means is 400 millimeters, the length of the drill bit. When I say drill bit, a lot of people freak out. They're worried about leaving a giant hole in the beam or beam pile, whatever it is, and what do I have to do to fill it? This is all it is for a drill bit. I don't even know if you can barely see that on the camera. 10 times out of 10, if you drill a hole in this with a graph, you turn around and talk to your other inspector and turn around, you're going to have a hard time finding the hole. So a lot of guys ask, well, should we fill it with silicone, the hole? I'm like, if you can turn around and find it, go ahead. But 9 times out of 10, there's a split or a check in the beam or pile anyways that's 10 times bigger than that hole. You're not going to go around and fill all those with silicone, so don't worry about it. In terms of durability of the bit, I was just mentioning to Dave, I've probably got almost 200 drills on my bit in here and I haven't replaced it yet. The unit has its built-in calibration. When it retracts the bit, it checks the bit, makes sure it's okay, and tells you it is, and then you move on. Once if it says it's bad, it has a pretty sweet feature where it unscrews it itself, spits it out, you stick the new one in, and it screws it back on. The unit itself is cordless, just a regular cordless battery, slips on, push button activation, nice setup screen, just telling you actually mine's due for service, but you need to send it in. They ask once a year for service. That's up to LTAP, not the users for that. And this is the main screen you're going to see. There's no danger in where you're pointing this. It's not like a gun. Nothing's going to go off. So there's several things to look at. This is telling you the angle at which you're drilling. So if you see it's supposed to change. Now you can see I'm at a 45-degree angle, and now it's telling me I'm past 45. That just helps you keep on a level plane or at a certain angle if you're trying to hit a certain spot. This is telling me, I believe there's 5 settings on the rate at which the bit can be pushed out. This is the middle setting. If it's a really hard, dense Doug fir or something like that, you want to back that down. You don't want to push really hard. You're going to ruin your bit. If it's a nice soft southern pine or something like that, you can increase it. I have typically just left mine at a 3, and I've been fine with anything that I've run into. If you get into something really hard like an oak, I would definitely back that down to a 2. Probably not going to see much oak on a bridge. The other number is the rate at which it's spinning. Again, kind of based on the material. I don't change mine much. I just leave it kind of middle of the road and get the results I need. The dial allows you to make some adjustments. If you really want to get down to the nitty-gritty and keep track of your measurements, you can go into the ID and you can give it a name. Here you can see I put 3M day. This was a previous demo day that I did. I gave it that label. You can also go in and put in more specifics about that specific location. Say if in the ID I put bridge number 45, here I could go in and say it's piling number 6, south abutment, north abutment, whatever. It just helps me keep track of them once I get in the office. If I'm in a hurry though, I'm not going to bother with that. I may just name them all bridge 45, forget about the rest, and then just keep track of the number of the file on my note sheet. That makes things a little bit faster, especially when it's 12 degrees outside in the wintertime. Other than that, not much else to know about it. We can get into how to use it on the actual sample we have here. Dave had one question, how do they know where they should drill? And basically that comes down to your visual inspection prior to bringing the drill out. I don't recommend using the drill every foot of every member on every bridge. It's not going to be it's going to be pretty laborious for you to do that. It's not going to be worth your time. You should spend a lot of time sounding just like you normally do in your inspections, possibly using the stress wave timer, which they also send out. That's going to give you that's going to really help you narrow down where you have bad spots. Once you know you have a spot that's bad through sounding, stress wave timer, maybe the moisture meter, then we bring this out to find out how bad it is. The other ones are just going to give you a location. This is actually going to tell you how bad the damage is. So the tip of this is a safety switch. It has to be fully depressed the entire time you're drilling. So if you're drilling and for whatever reason you let off pressure and that safety switch comes off, the bit automatically retracts. Okay, so what that means is that I have to have firm pressure on that safety switch at all times. So I'm pushing against it. Sometimes it's going to be convenient to do this. If you're higher on a pile, you really have to put a lot of shoulder pressure into it to get it, and sometimes it is difficult. But we just need to keep that safety switch pushed in. And I'm going to get a good set on it. And now all I have to do is push the red button. And you can see on the screen, you can watch it go through. It tells you how far in it is. We're at 4 inches, 5 inches, 6 inches. Now you can either measure your specimen ahead of time and know when to stop. A lot of times I just listen. I hear it's coming out the other side. I let off the safety switch and it automatically retracts. And you saw me there at the last minute grab that, and typically I have gloves on. For about the first year I used it, I didn't do that. And after about 100 or so filings, some of those small filings got backed up in there and it kind of clogged things up, so I had to have it sent in and redone. The easy fix to that is just to grab it with your gloves as it's coming out. You don't need to hold it tight. It just helps, your gloves help peel all that creosote and shavings off so that they don't get inside the bit. And you can pretty easily just pop that off and you'll see there's actually some inside there since I missed them. And that just helps keep things clean and working properly. So if you look at the screen, you can see we still have our last reading up. And it goes from 0 to 5. Our specimen was probably 10 or 11. If we spin the dial, we can scroll through that and we see it's actually 10 and a half. So first question people ask is, well, what does the number on the side mean? Is 100 the best? Is 40 the best? That number is just a relative number. It's the amplitude. It doesn't really mean a whole lot. If you want to get into the nitty gritty, you can do some more research on what that number means and so forth. It's not necessary here. It's all relative. So we see starting out, we have a good 30 or so, and every spike you see there is a growth ring. As the tree grows, it grows in different rates. When it grows fast, it's really hard. When it grows slow, it's really soft, and that's why you see the ups and downs in the growth rings. As we go through, we get to what they call the pith, the center of the tree. That's where it levels out. There's no growth rings. And then we get past that and we have more growth rings. So again, it's all relative. So if solid material is giving me 20 to 30, bad material would give me 0 or near 0. So we would look for a flat line in our reading on that graph, and that would tell us we have a bad spot. Some of the resistor drills, have a paper printout, and you can actually get a Bluetooth printer. For this unit, we don't have that. But the printout is scaled printout. So if I were to take the printout, for those of you who ever have one, and hold it up to the specimen, it shows me exactly where the bad spot is in the specimen. This one just tells me in inches. If I were to have one at 4 and it went to 6.5, I would know that 4 inches in, and for another 2.5 inches, I have a bad spot in that specimen. So what I would do is I would sound with my hammer. I'd use the stress wave timer. Say I found a spot that sounded suspect. I would grab my resistor drill and I would just pick a spot and I would drill in the area. If I found a spot that was bad, then I would move up 6 inches, move down 6 inches from that, try and bound the area that's bad. Once I do that, I would spin 90 degrees and go do the exact same thing so that I get a 360-degree view of what that quote-unquote cavity or void might be inside there. Sometimes all you're seeing is an internal split. You'll see a flat spot. It may not be a hollowed out. It may not be deteriorated. It might just be a split inside that doesn't go to the outside.
Does that just show up as a blip? Kind of on
It just shows as a flat spot as it's going across.
It would be a really short flat spot.
Yep, if I can, there is a split on this one. I can try and drill through it. So yeah, that's the point of going 90 degrees. So you can see, let me tilt this, see if you can see that. You can see this split right here. So if I drill across it this way, obviously I'm going to have a flat spot here, okay? But then when I turn 90 degrees and drill this way, I'm not going to hit it. So I'm going to know that it's a localized, very small bad spot, probably a split, not decay. Decay typically is more of a three-dimensional type location. So the other nice feature, a lot of times the area that we have in question is either at or below the water line. The biggest issue with sounding with a hammer is how do you tell anything bad below the water line? I mean, yeah, you can stick your hands in there and hammer with a hammer, but it's going to sound different. It's going to travel through water different. The stress wave timer works below water, so you can put those in, do your stress wave timer. And then the way we get around it with this is, say we had a water line here, I would put my drill here, and I would drill down at a 45-degree angle. I'd drill down below that water line as far as I could to try and locate the issue. Otherwise, I'd have to just wait until a dry period, come back, and then look at it then. But that is one way to try and get below the water line, is to go at a 45-degree angle.
Okay.
Keep going, keep going, keep going, keep going. Okay. There it is. So it's pretty subtle, but it's definitely a dip right in there. That's the check. We can change the amplitude setting in the graphing software once we download it to change the magnitude of the amplitude, and it helps bring out those low spots a little bit more. And I can show you some previous readings that we've done. One other thing that I should mention and to pay attention to, it's not too big of an issue when you're drilling through piling. I have it a lot when I'm doing timber beams, timber girders. A lot of them are only 4 inches wide. Some of them are 6 inches wide. If you're drilling up from the underside, the denser material has a tendency to push the drill bit. So you kind of got to watch both sides of the beam as you're drilling, because sometimes it'll want to walk itself out the side of the beam. And as you're watching the graph, you'll see a flat line and you'll freak out and you think, oh gosh, I got a huge bad spot in my beam. Well, no, your drill bit has just walked out the side of your beam. So you got to pay attention. Same thing when you're doing piling, make sure it's not coming out the front side, the back side. And I did mention to Dave, I should have mentioned this earlier, we don't have any issues here. I know there's no hardware in this section. If this were an actual piling, we would have back wall here with large spikes in it. We want to make sure and do our best to not poke that drill bit into a spike or an anchor plate, something like that. That's for sure going to ruin your drill bit. So the unit stores all of your readings, keeps them numbered. This is 181, and then you can just download them all in one big lump at the end of the day. That's how I do it. I don't do it bridge by bridge. You can certainly do that. I just wait till the end of the day, dump them all. I have on my chart which numbers through which numbers go to which bridge. I file them up. Pretty simple that way. So the unit comes with software. It comes in the case with you. You just have to install it on your computer. There's some drivers. Here I have several plots that I pulled up from a bridge we did in Blackhawk County. So if we look at this one first, these were actual solid sawn bridge beams. They're about 16 inches deep. And so you can see this one, again, the amplitude doesn't really mean anything to me. It's all relative. I have a really good solid beam there from start to finish. That one I had no issues with. I knew it was good going into it. Stress wave timer told me it was solid. The hammer told me it was solid, so I didn't have anything to worry about there. Not far away, we had a beam where we got a reading like this. So same thing, 16-inch deep beam. Now if you pay attention to the amplitude, and I'll scale it up a little bit here for you. Let me go a little bit more yet. So you can see the first inch on the underside of that beam, basically the tension side of that beam, good solid material. And from 1 inch to 15, there was absolutely nothing on the inside of that beam. Just some flakings of actually the bit even hitting anything. And then we've got another inch of material just before we get to the deck. So we had basically a tube section for a bridge beam. What happened? Probably insects, moisture got in there, decayed it. And if I imagine if you cut that beam in half, it would just be sawdust inside there, all chewed up and no good. So that's obviously something we want to know. That's pretty damning evidence that we can put in our inspection file, and a good resource to have, other than just the stress wave timing number was 300. The hammer sound was bad. This is more conclusive, quantifiable evidence than a typical inspection.
What it'll do is just spit it out if it's bad, right? When it's doing its check. And
Let
then,
me.
because I'm just curious if whenever if I have to change it out, what it entails.
Okay,
I'm
so
assuming it's
I'll
kind
show
of
you.
feeds itself in.
So over here, there's this thing looks like the end of the drill bit.
Mm-hmm.
Here's a wrench. I honestly haven't had to use these, luckily,
Yeah,
any.
yeah.
So if I go to the drill bit, it has auto
Auto and
or manual. Okay. So if I hit auto, so it's moving it to the change position. Now it's saying to hold the needle. This is probably where the pliers come in here.
Oh, okay. Sure.
So I'm going to hold on to the needle. Okay, now do it.
Oh, okay.
There. So it
And so
basically
it just
unscrewed
slides
it,
in and out.
and you can
Right.
see how nasty it is in there.
Mhm.
So let's
But
go
it's
ahead,
still a
let's
good
go ahead and put a
bit.
new one in since I've never done it. I'll slide that in there.
We probably don't need to hold on to it this time, do we?
Yep.
Or will we?
Yep. Okay, so just hold at the paddle.
There it goes.
It goes through its needle check again. Needle check okay, and we're ready to go. So the question Dave had was, how do we get the data from here to the computer? There is a Bluetooth option. I've never had good luck with that. Mainly, I tried it when I first got it to Bluetooth it from the bridge to the computer in the truck. Bluetooth doesn't work that far. That's not convenient for me, so I'm just like, heck with it. I'll just do it by cable and know it works. So on the front of the screen here, there's a little black slider that opens up a mini USB port. Plug the cable into that. Easier said than done. They put the handle in the right spot. And then you've got a regular USB on this end that goes to your computer. Go into the program, download measurements, and it automatically downloads them all. You can rename them, reorganize them however you want. Pretty slick.
Does the memory in the drill ever get full where you have to clear it out?
I'm assuming it does. Typically what I do after a project, say, I'll download, clear it all out, and then I start fresh.
Right. Which is what we would do.
Yep.
In-house. as
Yep,
opposed to
that way you
worrying
don't
about-
have
Yep.
other counties, other users downloading other people's information. And the batteries, just like any other battery, especially for these, I've never had an issue with a battery not lasting a day. Typically they'll last multiple bridges. We've done 3 or 4 bridges in a day with this, and that was high use, more use than a county's probably gonna do. So as long as you're charging them every time you bring them back to the office, you should be good to go.